questions, to type them in the chat box. We'll address them towards the end of the presentation. This is a great opportunity to connect with fellow attendees and our esteemed speakers. Please be sure to follow us on LinkedIn and start building those professional relationships. If you have Q&A, don't hesitate to ask your questions at the end of the session. Please note that the session is recorded, so you can revisit the content later in our YouTube channel. So without further ado, let's introduce our esteemed keynote speaker for the day, Jack Song. Jack Song is the engineering director of the Uber's data platform, leading data infra, data for AI, and AI for data and multi-cloud data enablement. Previously, as engineering director of AI ML infrastructure at Airbnb, he spearheaded groundbreaking initiatives such as data-centric AI, ML ops, and generative AI, contributing to platforms like Large Foundation Model Fusion Hub and the Airbnb feature and embedding platform. As VP at MasterCard, he led global data and AI platform teams across the US and India, overseeing 50 billion transactions daily and enabling AI-driven services on hybrid multi-cloud infrastructures. He got business analytics master degree at Northeastern University at US and computer science master degree at Southeast University at China. Let's give a warm welcome to Jack Song. And off to you, Jackson.
Thank you. Thank you so much. Thank you for the introduction. Let me share my screen.
Yes.
Okay. Can everybody see my screen?
Yes, it's visible.
Okay. Thank you. Thank you for giving me the great opportunity. I'm be so honored to be here, like a keynote speaker. Yeah. So today, I'm going to talk about the topic and how AI is reshaping the career pathway. I think a lot of like introduction already been done, right? So I can focus on my career pathway. So I had a 20 years of career path. Actually you think about the traditional ladder. So I grew from the intern, most of you, right? So the career path may be the same, right? It started from the intern and to be a senior IC role and transfer to senior engineer manager and couple of year and grow to executive leader for company. But very interesting. I'm maybe not so the same path like a lot of engineers. So I literally changed my role in my 20 years. I was a software engineer, I was data engineer, I was infrastructure engineer, and then I also became a machine learning engineer during my IC time. My expertise is most of AI and data and AI and back and forth. Sometimes focus on data, sometimes focus on AI, sometimes focus on the middle area for data AI. Yeah, being introduced, I have a couple of like industry experience from telecom, finance, and share economy. Here's my LinkedIn and my email. Feel free to contact me, and anything I can help, we'll be glad. Okay, so let me talk about the career pathway. So the first of all, it's like easy thinking. Anytime we talk about the career paths, so what we want, right? What we want to be. So I think in Silicon Valley, in tech company, we talk about, oh, I want to be a data scientist. I want to be a machine learning engineer. This is my career pathway. So, and what we are doing, so is try to get education, right education, not only on the school, but also in the work environment to like a strength and make my skill set is better to like close to what the requirement from this particular role, right? And better and stronger, though, and then I can have my career path up to the different level and the expertise. So that is the easy thinking. Uh, so before we go to the how the AI is reshaping the career path, I probably want to share some unpleasant truths. Right? So I think these two CEO are very popular recently on the social network, right? So the Shopify CEO Toby, right, mentioned AI is for everyone in Shopify. If you're not claiming and you are sliding. And the Fiverr CEO said, okay, AI is coming for your job and hack is coming for my job too. I'm not sure some of you, you're working with your company. Did you get the CEO letter or email saying, hey, I strongly agree with Toby said, right? So that's my requirement to all of you, right? You should use AI for everyone. So I think why recently a couple of CEO and industry leader they try to I don't want to call it, they try to generate the numbers for the engineer or data scientist group, right? Because there are a couple of like a fact I want to share. So 2 days ago, the OpenAI just make announcement, right? The leading edge codex, right? The coding machine from the OpenAI. So I think this is like so many like thing happening on the coding area as cursor, and entropy and so many macros, right? So like one thing, a couple of things I learned I after I deep dive at the red corner you see the OpenAI internal software engineering task. I think the OpenAI tried to release their benchmark. It's not just like a benchmark. This is real job, real task for their own company. 75% accuracy. What that meaning? That meaning the codex can do the similar or better job than the middle tier OpenAI software engineer who has the most outstanding talent in the world. Uh, that's quite amazing. And personally, I pay attention about the demo they show about how the codex to help on-call engineer. That's pretty amazing. Actually, the smart and intelligent codex agent can do a lot of work to be an on-call engineer. So in my own company, in my own organization, we have big trouble on the on-call. We have heavy on-call, right? How to help the engineer to relieve, to relax, right? So we are working on something similar like a data agent to help on-call engineer. But after I saw the demo, I know we have so many things to do, right? This is one signal. Another signal, talk about the overall market change, right? So this is from the FRED, so the index that talk about the software developing job posting. I just use 1 year as a whole year because a lot of time people see that the middle of 2024, AI start reshaping the software engineering work, right? So let me see what 1 year happened. So the 1 year we clear saw the decrease of the job posting demand on the software development on the United States. I don't want to see in the future there will be more worse, but here we can see the trend is so clear, right? Decline. Um, another I would say as unpleasant truth is the layoff is ongoing, right? So and we all remember the last of January is a was a very bad moment in Silicon Valley, and a lot of tech company a big layoff. But if you see in 2025, more than 61,000 employee being laid off in this 130 tech company. If you see the trend, right? So in 2024, a lot of companies started lay off. But in 2025, few tech company they lay off, but more people being laid off. So that's also very strong signal, right? The AI is reshaping. So not just like the job demand and also the requirement for the software engineer or data scientist relevant prediction on the existing tech companies. So another perspective, if you see the number, another interesting number is 10 years ago, we probably have 79,000 graduate students from the bachelor to PhD on computer science stats, right? So after almost 10 years, the number double size, right? What's that meaning? That meaning, okay, the demand dropped down, but we have more and more the new bird join the market, right? So you probably say, oh, I'm so sorry for those new and graduate students, they are going to hard to find job. That may be true. But if you think another way, they are pretty new, they're open man, they're easy to be weaponed by AI too. They have no legacy, right? If you think about that way, maybe companies are willing to hire like a younger engineer to use the AI and can do better job or this equalize job to the middle tier, like a mature engineer, right? That's possible. Um, I think we talk about the data scientists here, most especially. I think Jack, you talk about very in general, right? I know I got a signal too, but how about the specific on data science or MLE? So we are working together. Yeah, I think I also want to share the clear key trends I observed and go from so many other leaders. They had shared the same observation. Number one, the research area shift, right? from the regular traditional descriptive analytic to generative AI. And the role evolution also is changing. And a couple of years ago, we tried to debate what's the role between data scientists and MLE, a lot of debating and battleground, right? So, but the recent year, we saw that another new role in the market, pretty promising, and a new job demand is the AI engineer, right? How to leverage role between data scientists, MLE, and AI engineer. To think about the model evolution, we get used to work on so many different types of task-driven machine learning model, 100,000 in one company. But if you go to generative AI area, you most of the time talk about the model evolution is a fine-tuned foundation model and very few foundation model. And their architecture is very simple. I'm sorry, not simple. It's centralized, right? It's like the transformer and GPT model. And the thing about the skill set shift, right? The stats focus on the machine learning ops, right? But most of the time you're working on generative AI is how to do the prompt engineering, core large language model API, and fine-tuning the large language model, right? Very interesting about your focus, the evolution is your job focus, right? Before you probably spend a lot of time on create insight, to do the experimentation, right? Scale the AI service. But very interesting when you start building the generative AI product, you should pay a lot of attention, energy on quality and the experience. So yeah, so I think I talk about a lot about AI is reshaping the career pathway. I think the big question to everyone is what are we going to do, right? How we can pass forward, so for our career pathway. So I want to share a couple of tips and suggestions, maybe can help. Um, so for pass forward, so let me start the case study from Airbnb. I think I can okay to talk about that. So if some of you start use Airbnb, in case you talk to the customer service, right? You talk to some, agent like name is Sarah, it's like Peter. So actually they're not a real person, is AI agent, right? Some possibility, right? So okay, so that we call the Airbnb virtual agent is the fully generative AI driven the customer service agent. Very interesting. So when the Airbnb built the Ever system since 2023, so the data scientists and MLE, they shift the focus a lot from the traditional work to the generative AI guardrails. So why? So you think about the left picture, right? It's something like Maslow or the hierarchy of needs. So when people start using generative AI, most of the time the challenging is about, so how can I make the response, AI response is more like emotional intelligence. It's not just like, hey, safety, toxic, sentiment, right? It's about emotional intelligence, about empathy, it's about ethic, right? So when we start work at 2023, it's pretty fundamental function from the AI model. So the data scientists, MLE, have to work together to do a lot of work to improve the experience and quality for generative AI model. So there's some couple of example, right, on the right side, a little bit funny, like we use the AI to try to answer the question, right? Just for example, right, there's one customer, you know, he canceled the trip long time ago because he was sick, right? So when he want to cancel the trip again, so the AI agency, are you sick again? So it's a human being, it's a real human being. We probably don't ask this question, but the AI agent will say, "Oh, I have a long-term memory. I know last time he canceled the trip because he was sick. Maybe he's got same reason, but the AI agent forgot. So the context, right? So what kind of the voice and tone he should pay, he should put into the conversation between our Airbnb guest. Okay, so so that is a different type of work and focus on the data scientist and MLE. So I just use one example, right? It's a similar idea. It's a great movie. My daughter loved it so much. We called Inside Out, right? So the different kind of emotion. Actually, it's a reality when the Airbnb, the customer service conversation. It's hard to see the customer. They have a combination of emotion when they start a conversation, right? It's not so easy. I'm always happy or I'm always sad. I'm always angry. a very complicated emotion combination when they start a conversation with the virtual agent. So how we can make the virtual agent more intelligent, emotional intelligence that can able to stable A and B and B voice and tone, right? So then, if you say the right part is the focus, it's not like anything the data scientist or MLE done before 2023. They start training the multiple emotional AI agent. They simulate the group conversation with the trainable AI agent with the different emotion overlap. It's a permutation. You can imagine. It's a chat room, right? Like AI talk to AI, right? And then they use reinforcement learning human feedback to label the incremental training instruction, something good, something bad, right? And they continue to fine tune the large language model behind the virtual agent and repeat the cycle. Because this is became that's like a normal routine for the data scientists and MLE who are working on the generative AI application at Airbnb. So that I want to share the one example how the focus was shifted because AI is reshaping our career pathway. You change your focus, you need a different skill set. So then the next question is how to upscale your knowledge, right? Your skill. So this is a big topic. Maybe like another 30 minutes talk about that. I just want to personally recommend this great book from Chip, a very famous woman AI leader, right, in Silicon Valley. A great book. I read the book, fantastic. The name is AI Engineering, Build Application with the Foundation Model. If you want have you have interest about explore the AI engineering, if you are a data scientist, or you want to be an AI engineer in the future, that this book will great help. So another path forward, so is a very famous professor, we call Professor G, and recently he shared on the Twitter, sorry, X, right? The workflow in the past 24 hours, right? What he did, he tried to leverage the different AI tool to help himself to do the regular research. The data scientists have to do like research scientists. I have to do a lot of research. I believe so. So you can imagine he tried to use a different type of AI tool because they have different expertise. Sometimes some model work, sometimes some model did not work. But it's not a blocker for him. He tried to implore the different type of large language model AI tool to help himself. GPT-03 and Gemini 2.5 Pro and also Cloud 3.7, he was able to find the expertise and how to use them on his research idea. He did it. I think that the right line I highlight here, it is the future. No, it is now. So I heard not only professional J and a lot of people I know, they're using the different AI tool every day to improve their productivity, innovation, and creativity. And I think also the word from Professor G, everybody underestimates not only what is coming, but what can current being done with existing AI tool. So that's big learning.
अरे
So
यार
oh, we can answer a question right now. Okay, go ahead. Any question? Okay, okay, it's okay. Let's move forward. So, okay, I can pause here. Any question from the audience?
I think somebody's just unmuted,
I'm
Jeff.
muted. Okay, no
Yeah.
worries. So we still have time to answer question after the presentation. So let me move forward. Okay, so I think I shared a lot of like his information, made the audience a little bit nervous, right? I believe so. I think most of you already knew those things, right? So let me share some like encouraging message, right? So uh, and if any of you just listen and learn the Sakura Capital own AI Ascent 2025, which is like 1 week ago, right? So that was a great keynote presentation, right? In 2025, I heard, right? A lot of information. So I just abstract the two big learning from myself. I think I'm willing to share. I think hope for it help to everyone. So the first learning is the battleground, the application layer. It's a very interesting picture. 1 years ago, even those smart like VC investor, they were under the huge debating. So where is value chain, value proposition for generative AI? It should be on application layer or on the fundamental model or intelligent service, right? At that moment, minority people or the VC investor, they believe application layer should be the value chain. But at that time, most of people say, no, 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 no. It's just like a ChatGPT wrapper, right? It's easy to overread. So the battleground should be on the fundamental model. After 1 year, interesting, right? They come back to review and they found, okay, the minority of people they thought 1 year ago, they are still correct, right? The application layer is the battleground, is the value chain, the value aggregator for generative AI. It's not meaning the fundamental model or intelligent as service was not the battleground. The reality was, so it became super, super hard for normal people, normal company to get involved. So you can imagine last 1 year, so many company up and down, up and down. The company who focus on the fundamental model is only probably 4 to 5 in the world, right? They need a they need to have the plenty of the computer resource. They need money to survive. They also need a group the top talent in the world to able to continue the competition. Most of the people in the world on the company, so they already give up or they don't want to get involved. So, but the great opportunity, like if you are building the AI application or non-AI application, that's a great window was open, or the door was open. The remarkable value on application layer will be reshaped by AI, right? And do you want to get the trend as soon as possible? So, another big learning from the keynote presentation, they just recognize the pattern in revolution for AI in software, right? A long time ago, the human, we are using not AI or not AI, we use the machine like tool to help to do the mathematic, so many complicated work. And then recently, year for Cursor, so many like more machine assistant, not only on coding, but also on the manufacturer, right? So the AI or the automation became very important, like a assistant, right, for human being to improve their productivity. So the trend or the future or the existing happening, say, is human with machine network. So how to think about that, right? So you are individual contributor. Typically, you work with other IC, your teammate and your manager and other team, right? Make a project program. You have daily meeting. That is the normal routine. Think about this way. In the future, you probably work a lot of an AI agent with you. So the job is you train, you teach, you coach, right? You fine tune those AI agents, let them understand the mission, the task you want them to do, work with them, even talk with them, NLP, right? So let them work for you. So a single person with a group of AI agents, that's a human plus machine network, right? So, and I think that Sakura, so those investors, they believe and they define the terminology agent economic, right? So there will be very promising changing or direction as the AI is reshaping the world. And absolutely, when the AI is reshaping the world, is reshaping our career pathway. That means you have to learn how to work with the AI agent rather than other IC and human being. So, so I think that's the time to come back to do a little bit of summarization, right? So we need to move forward. We saw the AI is reshaping a lot. A lot of like nervous came out. So then we need a critical thinking. So this framework will a little bit help, right? So we say, what do we want? What do we want depending on the personal knowledge, experience. We want to be data scientist or we want to be AI engineer. And I shared a lot of reality, right? How the AI is reshaping our life. So there, and then between the want and reality in the middle is option pool. So what we should do is put the critical thinking on those options. how many options we have, right? I don't want to give the very concrete, like, instruction, do they do that, right? So just like open man, like there's a different type of option or paths so we can explore. So number one, if you go to traditional ladder, right? Think about I want upscale, I want to be the up level, right? So you probably think a new skill, generative AI specialization, AI engineering will be the precondition for your promotion, for your advance. Okay, let me give one example. A lot of companies, they how to measure the performance for engineer. They use the code commit, or we call diff, right? So diff count. Okay, you're good job, you're smart, you are work hard. Can you imagine? I know a couple of companies right now, right? So in the future, and the company will change their measurement KPI, say, I will see how big a percentage, how much percentage the cursor, you're using cursor to generate the code, rather than you own yourself write code, right? If that is the measurement, that's a strong signal. Oh, I want to be a good performer. It's not only I can contribute the code, it's how can I leverage a cursor or other coding IDE assistant tool to help me to have better productivity. And they contribute a lot for my code. I did my own job and coach them and make them have outstanding high quality outcome to meet the requirement for our software, right? So then I try to demonstrate the possibility will happening and already happened in a lot of company. The measurement, the OKI, the KPI would change for how to evaluate the data scientist or engineer performance. So the second option or part is literary move. Sometimes it's very challenging, right? I had a lot of conversation with a younger engineer that came to me, hey, Jack, I want to change my job to be from a data scientist or machine learning engineer to AI engineer. Can you give me some guidance, right? So that's what we call literary move. No title, no like a level change, but title change, job change, role responsibility change, the duty change, right? So seek opportunity to acquire new and in-demand AI skill, right? So if you get ready, you say, hey, I want to be an AI engineer, or I want to get AI engineering the skill. I want formally to move to AI engineer. So it's just a possibility. So for your career pathway from a good data scientist to a professional AI engineer in the future. So number three about the specialization, right? Specialization. So what we should put on the investment on our specialization, right? So a specific industry application of generative AI or a solely in a particular model architecture. I think I already shared my learning, right? If you focus on just the model architecture, I create a new model. I publish a paper, research. Hey, this is a new model. Let me say not a generative AI model, it's a regular machine learning model, right? To resolve some tasks, right? The people maybe come here challenge, or even you're from your own company, your senior IT or the leader coming, why you couldn't use the generative AI to do that? Why you need to create your own model architecture on that, right? So that's a possibility. People will challenge you. But don't get me wrong, even the generative AI is so powerful today, but there are still so many limitations for generative AI. For example, the latency, right? And then think about Uber and even the Airbnb. So the high throughput traffic comes here. I want to make a smart decision. Can I leverage the OpenAI model and to do the 5 to 10 millisecond response? No way. Okay, so like they still have like a long decision making process, but it depends on how you reshape your product design or application design and how to achieve the customer experience. Sometimes the user can wait, right? You don't have to answer so quickly. You can give them exploration, like a journey, right? Explore them to find the answer. Then they can spend a couple of minutes with you, right? This is the different way to thinking. But the overall come here. So, and as I said, application layer is the promising direction for the specialization. Try to understand some vertical industry knowledge and bring the knowledge, merge combine with AI technology and create a new application, new feature, there will be very, very promising specialization area. So if you are building your own startup or you are working with a startup, right, the entrepreneurial part is good for you. And so I talked to a couple of VC and the startup company and co-founder and founding engineer. So I had a strong signal from them actually. That I don't know how to see that in China with a lot of company, internet company, they are chasing like 996, right? But actually it's illegal right now. And can you believe, right? After the China government say, hey, don't do 996, right? A lot of company in Silicon Valley, they are doing 996, right? And somebody told me, oh, no, Jack, it's not 996, it's 007. Are you kidding me? Right? So because they are so nervous, right? So they keep trying to find the new opportunity for the startup, the direction. They have to work hard because they don't have to work hard. Other company can just beyond them so quickly. So, and right now the AI competition on startup is super, super challenging, right? So because people have to work hard to able to move faster and move ahead of the people and other competitors. So it's not easy. If you want to go to startup, welcome, right? So, and, but you have to get ready, right, to get you to the 996. So maybe the last one is you found the limitation is hard for you to move forward like on the current industry. So then you probably think cross industry transition, right? So if you go to the different industry, you have different opportunity. So try to identify some industry you can evolve in your AI and ML skill more and then you can transit how to transit the industry, just go to different company, right? So like my own experience, I learned a lot from telecom industry, and then I went to the finance and went to the internet company. I learned a lot from different industry. I know, but they have different like um, um, uh, advantage or disadvantage to give you different like AI skill. For example, in Mastercard, I set up with the world class like understanding and skill set and ethical AI or data governance, right? And data safety. So, and they're doing amazing work. So, but an Airbnb, Uber and more like leverage generative AI to help company. Okay, so I think we almost got time. So let me just go to the final slide. So no matter how many things we can do by ourselves, right? Try to explore different paths. So to be my honest, the most difficult part is your mindset shift. Are you ready to make the career pathway change, right? So again, I back to the chip. Um, uh, it, it did not just write book, and also a lot of like a great engineering blog, personal blog. So this one I highlight here is from her personal like blog, talk about measuring personal growth. This picture I just get from her blog, right? So very impressive, right? So what are you learning from this picture, right? So when I first time saw this picture, I was shocked, right? So I can get different information from the picture. It's something like, okay, today is the dividing line, right? Before you had one clear left path, including a career path. But in the meantime, you gave up or you pass, right? So many other paths in your life, right? Today, so after AI is reshaping the world and reshaping the career, the pathway, so what are you going to do? So as a human being, we are not fighting with our own like a teammate, right? So other human being, we are fighting with AI. So are you ready to explore the multiple paths in your life, right? You try to explore different paths, you get learning, you come back, you adjust your career pathway. I think that Chip tried to demonstrate her learning. She said she tried to become a new person every 3 to 6 years. And she tried to solve a big problem as soon as possible and the creating safety net and allow her to take a bigger risk and explore more things in the future. And she took action to help her to maximize the future option. That's a great learning from me. And also I want to share this to everyone here, right? So mindset shift is something you have to think, you have to get ready. You want to change your career path, you want to up forward. You need to get ready, your brevity, your determination to embrace the unpredictable change in your life. Okay, so I think I got time. So and thank you again for the great opportunity to me to speak here. So I think I can open the question and comment. So anything from the
Thank
Zoom?
you so
Yes.
much, Jack, for supporting WITS and taking time out of your weekend for this amazing presentation. We do have few questions I can read out to you.
Okay.
Uh, what new roles do you foresee emerging in the next 3 to 5 years due to AI disruption?
Yeah. Yeah. As I mentioned, right, AI engineer to be my honest, right? So it's one of the role. So another role I was thinking is like when I demonstrate the AMB the case, right? To think about the quality and the experience. So and I think a lot of companies right now they're thinking how to. It's another level of a QA. So, but they try to educate or retrain their engineers so to be more like focus on the quality and the experience. I don't know is it a particular role, but I think that's a very straightforward direction for engineer to move forward. Yeah. So and also the another role I think in the next 3 5 years is AI agent, right? So it's like a it's part of AI engineer, but it's something more like automation. So like for example, I saw some company they are hire on-call engineer, but they when they do the on-call engineer, they're not operational on-call. It's just like, hey, you should use AI to do the on-call, right? Couple of things like this.
Another question, in a world where everyone is building on top of the same foundation models, where do you see durable competitive advantage, workflow or UX or proprietary data or something else?
Oh, absolutely. That's an ecosystem. I think we spend too much time on foundation model, right? So, but the very few people, to be honest, I can share the approximate number. It's about 1,000 people in the world. They're really working on foundation model in the world, right? So we have a couple of million like intelligent worker in the world, right? So very few of them. So, and there are a lot of things on workflow, UX, and appropriate data, right? Should important play the role. But, but we have to rethink, right? So, for example, UX, the people say, oh my God, the AI can create a website, can create something like the UI web page, right? Actually, uh, mobile apps development in just a couple of minutes. It can. But again, right? So how to make the user experience feel comfortable and is a good understanding with your customer is we need a UX. But the UX should not just limit it, oh, the traditional way, how to tune the CSS, like how to tune the different layout or the button position. They probably have to employ the AI tool to create a more advanced UX experience. I can share another example. I don't want to say the UX engineer. Actually, I'm working with some very interesting like NPO and for the teenager or younger youths, right? AI for art. So that also interesting. Like UX is part of the art or the beauty, right? So and the people have to do they have the art experience. But I already saw and so many young kids, right? They try to leverage AI as an assistant to create art, right? So this is one example, right? How the AI can help the designer or the artist, right, to create the innovative and more creative work. The workflow, I will say, yes. Can you believe Uber has like more than 100,000 workflow? So even in the data platform, amazing. But at a lot of 99.99 of them is created by human being. Can you imagine in the future, the workflow is just a workflow, but created by the AI. And the AI come here to consolidate, reduce a lot of workflow. It's not meaning it minutes you create a workflow. And how can you use AI to create workflow? This is another type of track. Yeah. So, any more question?
Very true. Yes, we do have. Are you observing new hybrid roles emerge that didn't exist a few years ago in Uber? How are data and AI team adapting to this? Are you hiring talent that are more attuned with the evolving tech or making your employees upskill? What task have you started to utilize AI at organizational level at Uber for data and ML profession? There's a bunch of questions. Yeah.
Yeah, I think that those are great questions. So let me share some like experience. One of the reason I want to move to Uber um, is I believe the application layer, the domain specific area for AI should be more promising for my career path. Because when I was in Airbnb, I was leading the AI infrastructure. The to be my honest, and don't get me wrong, the Airbnb is a great company. It's not only Airbnb, it's like a similar other company, Netflix or LinkedIn, right? Even Uber, Stripe, right? They probably have the similar challenge. The AI infrastructure is a weapon, I have to see, right? So a lot of companies they don't have the opportunity or the necessity to work on large language model. Very few companies in the world they create their own large language model, right? So the AI infrastructure is more like a tool set to help the generative AI. I feel a little bit challenging if I keep doing invest myself on this AI infrastructure area. I make the decision I want to embrace application. To answer the question here, when I joined Uber, I think one of the reasons because Uber want to do the transformation like a lot of company in the data company in the world, like Snowflake and Databricks, right? So for example, Databricks just emphasize, hey, we are data intelligence platform, right? And Snowflake, hey, we are Cortex AI. They try to merge AI and data together. That I found a very promising direction, not only for myself, but also for Uber, try to bring the data and AI together. Not only data for AI, but also bring AI for data. For example, so before, so the data scientist in Uber is a data analyst together, all the people, more than 20,000 users on the data platform. They're using traditional way, the BI tool, the query engine to write SQL, right, to understand the data. So we published the Query Copilot. It's like text to SQL capability in Uber. So we have so many users, including data scientists group. They don't have to do so many hard coding and handcraft SQL. They can just easily to describe what they want to build the data insight. They talk to the Query Copilot and then they get the result, right? All get high quality SQL, meet their requirement, simplify their work. And recently, I'm leading the team to work on more like a data agent, right? A lot of data agent, data engineering agent, data analytics agent, data on-call agent, right? So many data agents because we believe if we tune the AI agent with automation, right? So they can help our engineer, our user a lot, right? To simplify, to automate their daily work. So, and then what type of a skill set I need for engineer? Just yesterday, I can share a little bit. I just shared the session. I asked my staff engineer, he's amazing, and he just used the cursor, and the cursor is not just IDE, and also the intelligent AI framework, right? He used the cursor to rewrite a query compiler, a new version in 2 weeks, right? I just asked him to share how not only use cursor, but how to leverage the market agent framework to rebuild the application or framework, right? So with a couple of engineers work 1 year, and how amazing like 1 2 week can just rebuild the application. So I mean not only to the Uber and also the audience here. So as I said, right, try to leverage and upscale yourself, right, and learn how to use AI technology and use your daily job. So I talk to my engineer the simple thing like, okay, if you are repeating something every day and you can write down the SOP, the standard operation procedure on that, then you should use AI to automate, right? Don't repeat the same every day, right? Couple of hours. And everybody should be encouraged to find the opportunity. Don't think AI is far away. You can use the AI to help simplify your daily work, but the problem is, and the skill, I don't want to call skill. Skill is easy to learn. It's a mindset or the determination. Are you ready? Do you want, right, to use AI to change your daily work? Yeah.
Thank you, Jack. That's amazing. You are almost giving mentorship on the career pathways, and it was an amazing talk. We do have few questions. Can I request you to answer them in the chat so that we can move on to the next
Sure.
speaker?
Absolutely. Thank you so much. Thank you, everyone. Yeah.
And off to Nihi to introduce the next speaker.
Thank you, Carl. So our next guest is Professor Xiaojing Dong, is a tenured professor in marketing and business analytics and serves as a faculty director of the Master of Science in Marketing at Santa Clara University. Her research focuses on leveraging data science and AI technologies to address marketing challenges. Her work spans multiple industries with a particular emphasis on social media platforms, e-commerce, digital marketing, and pharmaceutical marketing. As an innovator in marketing education, Professor Dong was among the first to develop a marketing analytics course for MBA students, integrating machine learning and AI into marketing problem solving. Drawing from her interdisciplinary expertise, she also designed and launched the Master of Science in Business Analytics program at Santa Clara University, one of the first of its kind in the nation. Professor Dong has collaborated with leading companies in Silicon Valley and China, including Adobe, LinkedIn, Atlassian, Fox, and Ctrip. She holds a Bachelor of Science from Tsinghua University, a Master of Science from MIT, and a PhD in Engineering from Northwestern University. Please join me to give a warm welcome to Xiaojing Dong.
Thank you very much for that very detailed introduction. It's great to see everybody here, and thanks, Jack, for your keynote. Jack is a good friend, and it's always amazing to listen to what he has to say. It's a great pleasure to be here. So just a little bit more background about myself. I think Xenia mentioned that I have all my training education was in engineering, but I'm now teaching in marketing and doing all my work in business. So I listened to that Jack mentioned about career path changes. There's if I can switch from being an engineering PhD and teaching in marketing, I think you can do every other changes if you want. So there are always opportunities, and hop on that when you are determined. So you need to have a dedication. I think that Jack mentioned. I just want to mention that because you can there. The world is dynamic. There are always new things coming up. So what is that best fits you and best fits you as your capability and your opportunity is it's always worthwhile of looking out. Okay, so what I'm going to talk about today is some of these AI applications. Basically, let me see. So the talk is going to be two parts. So the first part, I'll tell you a little bit more about what is artificial intelligence. I think Jack also mentioned that, every day now people are talking about AI. It brings a lot of fear to people. What is art? What is AI? It sounds so advanced. It sounds so sophisticated. But if we really have some basic foundational understanding about it, then you will not have that fear. And you will realize artificial intelligence is not something just came out of nowhere. It's actually been through a long, 70 years of development. So it's not scary. Basically, that's what I'm trying to say. And then I'll show you a little bit some of the applications in business and marketing. Okay, so that's my plan. whenever we talk about artificial intelligence, the first thing is to mention this person's name, Alan Turing. Many of you probably have watched a movie called The Imitation Game, which was actually featuring him. So he really was the person who designed the ideas or the concept of machine, and also he made a very provocative question. He raised this question of whether machine can think. Because if you think about the machine, it's really the foundation of the machine. It's just those zero ones, right? So they control these electricity to make these chips to contain many zero ones. If it's just all those zero ones, how can we make machine to be as intelligent or as similar intelligence level as human being to think and to understand our questions? So in 1950, Alan Turing published this very famous paper. And the paper basically, in this paper, he basically trying to say, how can we tell whether a machine can think or not? How can we tell whether the machine can be behaving somewhat similar like a human being? So the way he proposed is, let's have a third person as a judge, and then have two other people, two other person. One is actually a human being, and the other one is a machine. And ask them to type questions, right? To use text, and then as the third person, if the person cannot distinguish these two, whether it's a human versus a machine, that means the machine has intelligence level that's as similar as the human being. So that's the famous Turing test. That these days people are using this to understand, to sort of judge whether the machine's intelligence level. And if you have, I'm pretty sure many of you have experience with ChatGPT or these Google Gemini, or these different AI models. You sometimes, at least in my experience, I just feel it's just amazing how responsive they are in terms of producing text, in terms of producing answers. So there are tremendous amount of progress comparing to the 1950s. So, but in the past 75 years, it really went through a long history in terms of artificial intelligence. So, starting 1950s, people started considering this idea of how can we make a machine to be intelligent and to think more like a person. The most famous conference, and many of you probably have heard, is the Dartmouth conference. It's actually hosted by back then the professors from MIT, Stanford, and the people from IBM. So in that particular conference, they raised the concept, or they coined the word artificial intelligence. And since then, there are a lot of enthusiasm about building machine that can think like a person. There are a lot of trial and errors, but then you can imagine 70 years ago, there are a lot of constraints in terms of computational powers, like the chip development. That back then it was just way too slow, and the hardware resources was just not there. So and so it went through a first AI winter. Now we call it AI winter. Before it came back in the 1980s. So in the 1980s, that's when people started building these so-called expert systems. So the expert system basically just based on all the rules. So if you see this, the computer should do this. If you see that, the computer should do that. So they build all the rules to help. You can imagine they try to build these expert systems to help manipulating a machine, or checking on the red lights, the traffic lights, these kind of things. But the problem very soon arise is they find that these rules could be exploded, right? So the number of rules there are just too many rules, and there are also a lot of corner conditions, and that the computational power it's just not going to be able to support the whole system. So it went through another winter before it came back from the 90s. right? So in the 90s, and so this is the most famous one was probably IBM's Deep Blue, and then the Roomba, and then the early 2000s. So people started utilizing this data analysis in business, which is big data and business analytics. And really what happened that changed a lot of things is started in the 2010s, right? About 10, 15 years ago. And when this, the big data came into become a buzzword, right? So I graduated in 2006 with a PhD in engineering. I was working on some pharmaceutical marketing problems. So I got a job as a marketing professor, and right after I got the job at marketing, I sent a card. So the word big data become popular. So that's when I started building a data-driven marketing course, the marketing analytics course that I mentioned earlier. So this was really when the hype came up about big data and machine learning. So if you think about what really the key difference here is now we rely on data to train the model instead of relying on human being to tell the computer what to do. Now we ask the computer to look through the patterns from the large amount of data and connect the statistical methodologies with computer science technologies so that in order for the computers to be able to go through all the large amount of data and find a way to find patterns in that. So that's where the machine learning methods is comes through. So once this is built, and recently what really changed is that one very, very famous paper that talked about attention is all you need. That's using the transformer framework. So the transformer framework is just another framework. It's actually, you can think about, it's very sophisticated. It's super smart infrastructure, super smart structure in terms of modeling. But really, if you want to understand it, in a really high level, it's very simply, it's really just building multiple machine learning models. So it built all these different machine learning models into a structured way that they can communicate, and they have so they become very powerful that they can generate text. If you think about before the machine learning models, most of these models just trying to find the patterns, right? So these two words always come together, or when these things happen, something like, so when we do this, our sales increase. So they kind of try to find those kind of relationship. Um, but the transformer, instead of building upon that system and building upon sophisticated machine learning models and put them together, and not only for the computer to be able to understand the relationships, but also based on the understanding of the relationship, spit out something, right? So that's the generative AI. I think really it's 2022 when ChatGPT, when really is the generative AI that came out. People got so excited about artificial intelligence because the computer can actually produce a lot of things, not just code. That Jack mentioned using cursor, but also text, pictures, and that makes people really excited about the generative AI. So, but artificial intelligence, again, it's not something new. It has went through these up and downs. And the biggest thing is really about the past 10, 15 years when big data machine learning technology come in. And then on top of that, this is a transformer structure. So that's, sort of the basic kind of development of artificial intelligence. So this is just, this is a very famous quote from Eric Schmidt. He was the executive chairman at Google. He was the CEO at Google and the executive chairman. So he mentioned, like this was something he mentioned in 2003, 2004, about 20 years ago, right? So this was the moment when big data just draw a lot of attention from the public. So because I went through this process and also my unique position between engineering and business, so this make a huge impact and a big memory to me. So it's very easy for me to compare what happened 20 years ago with now, right? So 20 years later, there'll be something different. I'm pretty sure that's going to be the case. That's going to be the hype word. I'm not saying the technologies are going to be dramatically different. The fundamental methodology technologies is going to be the same. It's just going to be getting bigger and more sophisticated. So in 2004, 2003, I think he mentioned that there were 5 exabytes of information created between the dawn of civilization through 2003, but that much information is now created every 2 days. Right, so the idea is just now everybody's on digital device, everything's recorded, all pictures even are all digitized, the videos are all digitized. When I was younger, there people still use the traditional cameras, right? So in those days, those are not digitized. Now just think about how many data, how many digitized pictures and videos out there. It takes a lot of it just generates a tremendous amount of data. So data is really the field. Once we have the field, then we can build a larger and bigger machine. We can build larger and bigger engines. So the machine learning algorithm and the deep learning, and so the machine learning, deep neural net, deep learning, and then now we call it AI models. These are all engines. And these are just smaller engines and now become bigger engines. So they can whistle the fuel, so we can really fly the rocket. So as I mentioned, I want to sort of demystifying the AI a little bit for the audience, because one of the things I noticed among my own students, I teach at the graduate school, teach at the business school at Santa Clara, is there are many of them are managers and directors in their own company, but then they work with these engineers, they work with these data scientists, but whenever it comes to machine learning and AI, they feel scared. What happened? Okay, is that everything okay? Okay, so really all these AI models is built upon a sequence of more sophisticated machine learning models. So let me just tell you what exactly is machine learning models doing for you. So there are many different types of machine learning, and it can get, but if you think about, I think the most foundational kind of machine learning thinking can be represented by this particular model. It's called a decision tree model. So let me just show you very quickly as an example. I noticed there's some chats, but I can't see them. So if there's any attention that I need to pay attention to, so just let me know. Okay. So let's see, suppose we have a data set here. Each row of the data shows one person. And so we have one metric. This is the important metric we're trying to understand, which is trying to see what kind of people is fit, what kind of people is less fit. And don't ask me how I got these information. So it can be from some doctor's evaluation, or can be from some self-evaluation. Right? This is the variable we are interested. And we have some information about each individual. So we know the age, we know whether they often, on a regular basis, they eat pizza, and whether they, on a regular basis, they do exercises, right? So just some basic model. So the idea is we want to understand what kind of people can be more likely to be fit versus unfit. So the idea is if we have somebody else, if like for myself, if I know like I put in my age, whether I often eat pizza or whether I often do exercise, the model can spit out the probability that I'm going to be fit or unfit, right? So that's the simplest model possible, right? So this is called classification models. So the idea is, can we, whenever we have some new person come in, can we do a correct classification, yes or no, fit or unfit, good or bad? There are a lot of, so it's one type of prediction model, right? And so if you look at what the model is doing, is really trying to look at, find, so there are three variables, right? So they try to see how can we find which one of the variable is most likely to split for fit and unfit. Right, the model goes through its algorithm. So there are these algorithms to help the model to pick the one variable to see, okay, this variable age is is very important in splitting people into fit and unfit, right? And then what's the cutoff? And so the computer or the algorithm will find, oh, it's 30 years old. Okay, so the computer, so the first layer decision made by the model is, okay, the model is going to be split by this age variable, and the cutoff is 30 years old. So okay, now so the data is going to be split into two parts, right? All those people younger than 30 years old and all those people older than 30 years old, right? Among those younger than 30-year-old, we still have some people fit, some people unfit. Okay, what is the next variable we should use to split the data? Oh, we find, okay, it's eat pizza or not. So once eating pizza often, it's unfit. When it's not eating pizza often, so it's fit. So that's kind of the process. So a computer is not intelligent at all. So, but computer really needs these kind of structure to tell computer what to do. And computer is super good at doing something very systematic and always repeating. Human beings hate doing those repeating words. At least I do. At least I hate them. If it's something that I have to do it so many times, and it's really boring. The computer are very good at that. So if you give them a very specific rule, and then they just follow those rules, they can make magic, right? So this is the very simple decision tree model. Right? You can imagine when the data has become big, and it's not very easy to find. We call these the leaves. So we want the leaves to be only, so like we see in this leaf, we want, after this splitting, only all the people falling into this leaf are the same. They are all fit or they are all unfit. But that's not possible, right? That's very hard unless you split, the leaves in the same number of data points. That's possible. But we don't want to do that, especially when you have millions of data points. So, but when do we stop? That's where statistics coming in, right? So the statistic will give you a suggestion about when it's worthwhile, when it's not worthwhile, keep going deeper, right? So this machine learning is actually when machine learning first became popular in the early 2000s. People were talking about, this is really when the two fields, statistics and computer science, actually started working together, right? Because they need both sides. So for the statistic, they can give you suggestions about how do you sample data, and when you get this information, how much that mean to the whole population. How can we utilize these models to predict what's going to happen with the other data? So there are a lot of statistical rules that can help you do that. And the computer scientist will help you design these algorithms. So you can tell me this is your rule to estimate the model, but the computer scientist will find a way, will find the algorithm to go through all the data point and find, okay, age is my top variable I want to use, right? So So once we have this, you can imagine this is super, super simple. But it can be expanded to many different dimensions, right? So one extension actually from those very simple model is the neural network. The transformer and generative AI model is actually built upon a lot of neural network models, right? So, but the neural net models is built upon these very simple tree-based models. And the neural net model is actually, it looks very sophisticated, but it's very simple. So, like for example, when we try to understand this picture, right? So a human being is very good at identify these patterns, right? We see this is a bird. But to computer, how can we make a computer to recognize this is a bird instead of, I don't know, a chicken, right? So the computer does not see the picture. The computer sees what? The computer sees pixels, right? So each picture is a combination of thousands of pixels. And each pixel is what? Each pixel is just three numbers, red, green, and blue, right? So each pixel is just three numbers. So to computer, it's not a picture, it's a bunch of numbers, right? And these numbers are arranged in sequence. So like this, the first pixel, the pixel on top of the second pixel, they have different values, but these values also has a space relationship. Not just one is higher than the other, but also these two are next to each other, and those two are next to each other. So they also have the spatial information within that data. So that's how pictures are different from the PISA data, right? The PISA data is just you just larger than 30 or older than 30. Look at
Who did everything?
you look at the value themselves. Here you also look at the relationship between these pixels, right? So that's when the so-called convolutional neural network model was developed. So the convolutional neural network model is basically neural network model, but also consider this relationship among these pixels. Okay, and so once you have these data, right? So it's a spatial identified large matrix actually. And what you do is you want to put in a neural net. So what a neural net is doing is super, super simple calculations. So let's say each of these dots is one of the data points on the picture, right? And then this is the input layer. So the input layer has all the data information about the picture, and then when it goes to the next layer, before it goes to the next layer, so each picture, each dot, let's say it's a number. When it goes here, it conducts some calculation. And how do I go from here to here or go from here to here? You see the lines. The calculation is just two-step. Multiply by something and then add something. Right. So like you can find, let's say, which number I should multiply, which number I should add these two numbers. So let's say I should multiply by 2 and then add 3. It will come here. So it's another number, right? And once I come here, what is the number I should multiply and add? So once you find those numbers, you will go to the next layer. And then you will get to the outcome. The outcome will tell you, okay, this is a bird. It should be the number, this one should be the largest, right? So but then the question in the neural net is at each node or each layer, what's the number I should multiply? What's the number I should add? And that's where the most famous person you probably have heard. Do you know who I'm referring to? Geoffrey Hinton. Right. So Geoffrey Hinton, actually, it's in my next slide. Geoffrey Hinton and some of his colleagues actually developed this methodology about finding the number to multiply, the number to add in 1980s. he actually got Nobel Prize last year because of that paper. Right? So again, as I mentioned, these are not super modern technologies. These are, these methodology. So he's a computer scientist. This is the way he developed the algorithm. It's called a back propagation. And so this is a back propagation is really extremely important in developing neural net. And that's why he was considered to be the godfather of AI. So he developed this methodology 40 years ago, and I find that people build upon it in the past 40 years and now become a really super powerful thing. Right? So that's the convolutional neural net model. It's looking at the pictures, spatial connections as well. And the other one is recurrent neural network. It's for text. And so like I type all these words, it's easy for us to understand what I mean. But for computer, they need to understand that what I was talking about. So they need to look at the sequence of the words, right? So the sequence not just next to each other, but also something before, something after. And then looking at all of them together, the computer can fully understand, okay, this sentence is different from that sentence. And this sentence is more related to that sentence, and the second sentence is more related to something else. Right. So these two neural networks are, once they are developed for pictures and for text, then we can try to explore more information from the data, right? So like before, when I talk about the machine learning models, we were looking at only numerical or structured data. Now we can look at pictures and text. And so these are more natural language, natural human language kind of models. Okay, so I want to make sure I'm following my time. What time do I have? Until 10:30, right?
Yeah.
Okay, so I want to finish up this and then leave some time for questions. So that's the basic. So I just want to make sure people do not fear about AI anymore. It just built upon those very basic models and getting bigger and bigger. And what really changes everything is actually way before what we know now about about ChatGPT. So this was 2012. So what happened in 2012? I don't know if you guys have heard about another famous name called Li Feifei. So Feifei Li, she's a professor at Stanford. she's so she put what she did is she put together a competition. Basically, she was doing computer vision. So computer vision just trying to understand all these pictures. Like we can see on this picture, there's three people, right? How can we make computer to understand it? So she and her team put together tons of pictures from the internet, and then they put to the community, and then say we have a competition, so you guys can come. So every year there's there's some people come to propose some algorithm, and then the purpose of these algorithms is to try to understand whether the computer can understand these pictures. So in 2012, these three gentlemen, Ilya Sutskever, Alex, and Geoffrey Hinton, they put together an algorithm based on their convolutional neural network. They realized, Geoffrey Hinton developed this methodology a long time ago. They realized they can actually utilize it to understand pictures. So they put together, and then they participated the competition, and their approach is just so much better comparing to the number two. So that really draws people's attention about what exactly they did, and they call it AlexNet. So that's actually the convolution based on the convolutional neural network. And that information leaked out. So companies like Google, Microsoft, Meta, it was Facebook back then, Google, Microsoft, and Facebook, and then a couple of Chinese companies, all of them want to purchase their algorithm. So they were like, okay, how can we sell an algorithm? So they were at University of Toronto. So they consulted with their university lawyer. So the lawyer said, why don't you three form a company? And then you can sell the company instead of sell the algorithm because the company can be a little bit more worthwhile. So they did. Guess how much they sold for the company? They sold the company to Google. They sold for $44 million. So just a paper, just an algorithm, and then all three of them was working for Google. Geoffrey Hinton actually just recently retired. I think 2023 he retired because he is afraid of all these AI developments. He wants to be able to freely criticize that, so he doesn't want to work with Google anymore. And Ilya Sutskever, many of you probably even more familiar with him. He was the one that kicked out Sam Altman, and then Sam Altman came back at OpenAI. He got kicked out. He started his own company. Now his own company worth billions of dollars. So that was kind of what happened. And then let's rewind 10 years later in 2022. So ChatGPT launched GPT-3. And so that's really when everybody got so afraid and the AI become such a big buzzword these days. So just to give you some idea, I think Jack mentioned that, building these foundational models is super expensive. They are. ChatGPT-3 had, like, when we look at the neural net models, I said, what's the number to multiply? What's the number to add, right? So each node has two parameters. And if you build a large neural net, if you build a large, have thousands of nodes, we're talking about thousands of parameters. It's already big, right? But the transformer is built upon many of those neural nets. So these GPT-3 was 175 billion parameters, and GPT-4 is 1 trillion. And the one that we are using 4.0 is 1.8 trillion. And just 2 days ago, May 15th, there was a Wall Street Journal article talking about GPT-5. OpenAI, I think last year they announced they were going to launch GPT-5, but it has been delayed because just training the model requires 6 months. But then when there's an error, they delayed. And I think Meta is also announced that they were going to launch a new model, but they also delayed. So everybody is delayed because if you look at the number of parameters, it's tremendous, right? So that's why it doesn't make sense for so many companies to train these baseline models. So I'm going to skip this. Let's just talk very quickly about these applications, right? So now all these high-tech companies, every day there's some news about these high-tech companies, whether it's investing or integrating these AI models capabilities. And so for us, at least for business applications, and even for engineering, for most people, I think really what do we care is how can we leverage these large language models that's already built and to generate values to us, right? So I'll just give you some examples that in business, UPS can track their trucks and try to find the way to reduce cost. So one very famous thing that they did is they based on these data and based on these AI models, they were trying to route their trucks by reducing the number of left turns. Why left turns? Because left turn has two problems. One, it takes time because right turn, usually you don't have to wait for the red light. Left turn, you do. And the other thing that they find is most of the accident. So left turn is more likely to have accident than right turn, right? So they can use this approach to reduce cost. And this is very famous from Amazon. They can base on your pattern to understand what you are interested in purchase. And then there's some recent article about how retailers are using these AI models to fight returns because returns are a tremendous cost to any retailer. I'm pretty sure that all of us have some experience of returning, but that's So they're also, this is Amazon, trying to understand what people are talking about the different products. Like, so they talk about, quality, insulation. So these summaries are all based on AI models. And companies like, this is Salesforce. They connect their customer data with to generate personalized emails. Say they look at the customer database saying this is customer that been with us for 5 years and they haven't purchased this product, so they can automate the email generation process. There are many other applications, so the time is short, so I'm not going to be able to go into the details, but I'll be happy to take questions if we have time. Thank you very much.
Thank you, Professor Dr. Dong. So we don't have time for questions, but they are in the chat. So if you could take some time to answer them there.
I'll be
Thank
happy
you so
to.
much.
Thank you.
Thank you. Okay, so now introducing our next guest, Sowmya. Sowmya is a postdoctorate scholar in the space of trustworthy AI for medical applications at Stanford School of Medicine. She works in an interdisciplinary sphere with clinicians and computer scientists and believes the tough problems are at the intersection of theory and practice. Previously, she worked as a researcher at Leibniz University, Hanover, Germany, in tandem with the Medical School Hanover on molecular implants and genetic modeling. She received her PhD from IIT Madras on AI, representation, and reasoning, all components of trustworthy AI. Please join me to give a warm welcome to Sowmya.
Hi everyone, thank you for inviting me. Let me get started by sharing my presentation. Is it visible?
Yes.
So, can I get started?
Yes, you can get started.
Okay. Hi everyone, thank you for inviting me. I'm Sowmya, I'm a postdoctoral researcher, and today I'm going to talk about trustworthy AI in medicine. So the key idea of my presentation is that GPT-4 and similar LLMs have a lot of potential for healthcare applications, but this is also a domain where if the technology is not trustworthy, it can have potential risks. How do we measure that? How do we mitigate that? That's going to be the focus of our presentation. So first things, why do we need AI for medicine? Is it more of application of a tool? What are the facets of AI that are interesting for medical applications? Then we'd move on to what is trustworthy AI, and I'll discuss 2 research case studies I've been involved with where we use these principles to improve the outcomes. So to start off, now that AI is the buzzword, I was interested to know when was the first AI program for medicine designed. I was very surprised to find out that it was all the way in the 1970s, before this big LLM boom. So why was AI used for medicine for so long? Well, from the early 1970s, we've had programs that look at data and statistics and figure out diagnosis patterns. So the program MySyn was quite popular as a tool for AI in medicine. And a lot of such expert rule-based systems came up. And the reason for that is we could collect data faster. A lot of medical institutions in the US were collecting patient data and feeding it into these models. And it also brought about a kind of homogeneity in the electronic health records, and that facilitated better processing. So in the expert systems, we have a lot of advantage of statistical analysis and reasoning. today, in the era of large language models and deep learning, we see that promise being used in multiple directions since we have access to so much data, but we didn't have access to so much computing power and modeling. So one of the case studies is improved diagnostics and imaging. Another case study is personalized medicine. The way medicine works is we have randomized controlled trials, we find out what works for a majority of the population, and we try to give such treatment. And we hope that by using AI and more complex data analysis, we would be able to give more personalized information than what a clinician would be able to do based on their experience. We also have help of AI for drug and protein discovery. And in 2024, the Nobel Prize in Chemistry went for AI for such protein design. With these kind of case studies, what has happened is we've seen an exponential increase in the amount of products, technologies that use AI in healthcare, more so commercially being adopted as well. So, does this mean that AI is always useful, promising, and so on? Well, we have this issue which is quite popular in the research space, which is known as the distributional shift. AI tools are built on the assumption that the past data is a reasonable approximation of the future facing world. Unfortunately, when you have disruptive events such as COVID and the pandemic, a lot of these models don't help. And this particular case study was actually about COVID related tools that were built to detect COVID, but they didn't help. So a lot of research is being done on how do we mitigate this distributional shift? How do we make the training process better so that we can generalize in real world settings? And it is still a challenging task. The case studies I showed before actually show success in very niche fields. So if I say personalized medicine, we're using AI, it's not like it's all the AI tools are able to produce that, but say a particular case study of sepsis control, we are able to show enhanced improvement. And that's where we see a lot of promise, where we have controllable parameters for applying AI. So now that we've seen how AI has been used for medicine, we'll now shift our focus to trustworthy AI. I asked ChatGPT to generate a cartoon to say how trustworthy AI is in healthcare. And you can see here, it says trust few, I don't know, and other issues. So when I see this text, I'm not going to trust such a system that makes spelling errors, even though the image looks very nice. And these are, of course, issues we have in vision models, but the idea I'm trying to convey is that trustworthiness is hard to quantify, and it's also a relevant task, and LLMs have not solved all aspects of trustworthiness. So these are some of the principles that's been given by policy documents. We're also in an era of AI where we are at the intersection of technology, policy, tech and research and everything. So this particular set of slides is taken from a government policy. So trustworthy AI principles include being fair, that your decision making is equitable and you prevent bias. We'll see some examples of this. The second is it's transparent. The AI process should be understandable to stakeholders. The third is it should be responsible, so which means there is some mechanism for accountability if something goes wrong. It's safe and secure. It protects against vulnerabilities, hacking. There's privacy, especially in medical information. You do not want your client's information to be compromised. And finally, it's robust. So when I use it in one scenario, I see repeatable outputs, and that also touches upon the distributional shift problem I spoke about. So first principle, how do we ensure fairness? Well, first we start by being aware of the biases that exist, and I've just taken two of them as an example here. One is the automation bias, which is a lot of clinicians and practitioners might tend to believe what the AI system says. And we see this when we correct emails with ChatGPT. If it looks very convincing, we might not read the whole text. So this automation bias is a problem. The second one is missing data bias, where we don't collect data from all demographics for our algorithm. The second principle is transparent. Now, this is hard because most AI models and LLMs are black box. That's the norm. So we can ask it to explain, but there are aspects of it that are not accessible to clinicians. So how do we use AI and make it more transparent? The third one is being responsible. Now, accountability is hard with AI because while we have principles such as we use human in the loop, how do we assign responsibility if something goes wrong? Is it the designer of the algorithm? Is it the human in the loop who signed off on it? There are so many ethical questions here. One mitigating strategy that we've been using is we don't use human in the loop only for evaluation, but we also use experts in design, in validation, and so on. So that way we are reducing and mitigating the risks. But the question of accountability often can lead to the human expert becoming a scapegoat, and that's also a reason why interdisciplinary conversational collaborations are quite hard, and we are working to bridge the gap. We need our LLMs to be safe and secure and protect against vulnerabilities. In a clinical setting, what does that mean? Do we have open source LLMs? Do we host our LLM on standalone server? There's so many questions there. Finally, we have privacy. There was a study a couple of months back where if you could, I think, ask information about yourself, you might find your address or something like that. So we do not want that happening with patient information. Then we want it to be robust, and that's again difficult because it's so hard to get repeatable LLM responses. So the whole idea of this discussion of trustworthy AI is that trustworthy AI is qualitative. We have a bunch of guiding principles, but it's quite hard to say, I have two systems and this system is 26.5% trustworthy and the other one is like 75% trustworthy. What we have is that we try to make it better. So I'll try to explain these qualitative concepts with two case studies and research works I've been associated with. The first is a genetic epilepsy diagnosis, where the problem statement is I have a few phrases of symptoms and I have to report the top end diagnosis in the field of genetic epilepsy and I have to explain them. And the trustworthy principles is, as is the case with most medical research, that we de-identify the patient information, we extract the pieces of information that are important, and then the second one is it should be explainable enough that if a clinician or a healthcare practitioner looks at the diagnosis, they will be able to understand which symptoms related to that diagnosis. So when we received this problem, we thought this is quite straightforward because the symptoms are in natural language. The database that had the matching between the symptom and the disease was also in natural language. We thought it would be quite straightforward. First, we asked the LLM to directly diagnose the input phrases. And then we thought maybe that would be difficult considering this is a niche field. So we actually gave our database and then asked it to match. Third, we also used a RAG system where given a symptom, we tried to match based on the database. To our surprise, it actually failed. LLMs are designed for language. We did not expect that to fail. We had followed all the principles of making sure we're working in a niche space. We tried using medical specific LLMs, and the performance was pretty bad. Then we started to look at how the data is, and in a more detailed fashion. So this was our problem. The first thing is, given your input has only two symptoms, say absence seizures and global development delay, you'd be interested to know that absence seizures is not the absence of seizures and it's a particular type. So these are some language issues that are there. But the idea is that the database has an exact match for absence seizures and global development delay as a particular disease. But the database, as it has been filled over time for the last 50 years, has so many variations of the same symptoms. So it's absence seizures, seizures absence, seizures particularly absence, and so on. Similarly, for global development delay, I've included versions of development delay, but there are other very different phrases. While a RAG system can easily pick out the phrases, it gets overwhelmed with the hundreds of entries which basically mean the same. So this was the problem we had. And when we use AI and ML, often we don't realize that it works only when the quality of the data is good. When we have such a legacy system with 50 years of information, then we do face such problems. So this was the research gap. The data collected was messy, and this is what I was talking about, that the frontier between theory and application is exciting. So what did we do? We tried to use the Trustworthy AI principles. We tried to reduce the space of the LLMs by sticking to a RAG model. The RAG model was getting overwhelmed, so we came up with a technical solution of clustering it so that the RAG would perform better. And because we're using a RAG model, it's more robust, we get repeatable outputs. And we also use open source LLMs for the process. So this was our architecture. We had disease to symptom mapping. And what we did was we took all the symptoms and we clustered them. And so then we had a disease to cluster mapping. And at runtime, the symptoms would be clustered, and then we would retrieve the diseases that had the most coverage. So once we have this architecture in place, we tried to implement it on a synthetic data set where because we have the database, we just used LLMs to create queries and we evaluated on that. And we tried a lot of open source LLMs, a lot of clustering methods. And this is also something I've seen in practice. I don't know how far, it's just heuristic for me. And maybe there's some studies there that I'm not aware of. And I've often found that larger LLMs perform better than smaller domain-specific LLMs. So that's just been my experience, and I may be wrong. Then we used it on our actual clinician data where we use clinical inputs from Stanford Hospital. And we found a method to do much better, more explainable. If you see the numbers, they're not very different. But if you see the quality of the retrieval, the explainability, it's much more. And we're working on increasing the size of the data set and seeing how it performs. So this was the first case study. And the idea was to make it more explainable, more robust, and so on. So the second case study is also on biomedical database. So the last one we saw OMIM. This one is the biosample. Now biosample is the largest biomedical database available on tissue samples, so many other types of samples. There are almost 5 million entries, and the idea of hosting such a database is that we want to democratize science. We want information available all across the world so that we can study different demographics and so on. So the key aspect that makes biosample interesting and exciting is that we can search it. Now, traditional search methods depend on good quality metadata. So here we have that tissue is lung cancer. Now, a clinician might have put this in here because you want to say that the tissue is cancerous. So it's from the lung and it's cancerous. However, the indexer is built to find tissue lung and health state deceased, and the disease is lung cancer. So it did not retrieve this sample, even though it's pertinent to my search query that I want maybe lung cancer samples. Similarly, we have a lot of errors in this way. And without good quality metadata, we can't proceed in search. So we tried to prompt our LLMs to correct it. And what we found is without structure, there tends to be a lot of language generation. We also experimented with a lot of temperature values and so on. But still, we were finding it difficult to repeat this process for, say, thousands of fields. And we know this in prompting that we need to make the prompt as specific as we can so that we can make it repeatable. So then what we did is, in order to help us create that kind of structured prompt, we actually used a metadata database where it tells us what the values should look like, what are the values that exist. For example, here it says, in biosample, blood occurs 50% of the time. And these information sources help us develop the prompt such that we can clean up these biosample entries. So we give a more detailed prompt. I just have some excerpts here. And the idea is we fill in the template more, it's repeatable, and so on. And we find that the search engine and the indexer is performing much better once we use such a structured prompt. So we started evaluating it. While evaluating, we saw two versions of evaluation. One is an automated evaluation where we took particular field names that had the most errors, which is tissue, disease, and cell type. And we found that using our prompting method, we could perform search better. We could make the field names adhere to some values. This is one of the important aspects I wanted to highlight, where we have peer evaluation. So by peer evaluation, I mean that we chose three reviewers who were not part of the development process, and we asked them to evaluate the quality of the corrected samples. And we showed that since these were the practitioners that were actually using the database, they preferred our prompting method that was based on this knowledge source. So what were the trustworthy AI principles here? The first is explainability. People can see the prompting, people can see the template, people can see how the search has improved. And the second is it's transparent. So we show both the source biosample record and the corrected one, and the practitioners can see both side by side and decide whether that particular biosample record is useful for them or not. So So, what are the key takeaways for both the case studies? The first is we use peer evaluation or clinician feedback. A lot of AI systems for medicine and startups and research work are being developed in silos where we have clinicians who know AI trying to build systems, or we have AI practitioners who don't interact much with the domain experts. So the idea is that we need to work together and we need to work from the design phase itself. So for both the projects, we had advisors and practitioners who interacted with the algorithm development. And the second key takeaway is that we used a reputable knowledge source. So we use databases, or we use a mechanism to make sure that we understand what the output is. And this is a way of introducing structure and trustworthiness into LLM and AI models. So that brings me to the end of the talk, and I would like to add some key takeaways from my discussion. The first is LLMs are transformative, they are disruptive, and we have a lot of potential. But we need to ensure that they are developed in a safe and equitable manner. The second one, trustworthy AI is hard, it's qualitative, but it is the way to go. And as we make the applications more and more trustworthy, the more they'll be deployed, the more clinicians and AI can work as team members to solve a problem. Language is still not solved. LLMs have not solved all the language problems in the world. And the interface between theory and application is super interesting. So the key takeaway is that we need to collaborate. We need to find the strengths. AI can look at millions of data points, but humans are the ones who have the experience to make sense of that data and apply it in the real field and in real time. We often underestimate how less time is available to make these decisions, and it's nice to have tools that tell you what are the different facets of application. Yes, thank you. These are my social media handles, and I'm happy to take questions.
Yeah, yes, so we have a couple of questions for you. The first one is, for someone without a background in healthcare or bioinformatics, how challenging is it to break into this field? What steps can one take to build relevant experience and deepen their knowledge in this domain?
That's a great question. I did not come from the biomedical space, so I can answer that to some extent. So during my postdoctoral training, I was assigned a lot of medical projects, and I think um, the first thing of breaking into this field, I would say, is also understanding the intuition behind models, not just the application or the code. For example, I was in a project where I was told I'm given a lot of data, big data, GBs of data, and I can do amazing things. But the GBs of data was given to me for only 10 patients, and there was nothing I could generalize from that. So, clarifying the assumptions of your algorithms and talking repeatedly with stakeholders helps when you're in that kind of space. The second thing I would say is that engineering or AI principles are quite different from the biomedical principles. For example, when we have, say, an inheritance kind of concept, we say that X is a type of Y. But if you ask clinicians about DNA and gene, they'll say DNA is part of gene and gene is part of DNA. So you need to understand the domain concepts from the experts. And third, I would say now is a great time to be in this field because we always had this problem of having less data, but now public data sets are all on the rise that we can do the secondary analysis of medical data.
And the next question is trustworthy AI in medicine fundamentally different from other domains? What principles are universal and what challenges are unique to the healthcare context?
That's a great question. So the policy document I took Trustworthy AI from is agnostic to medicine. It's all all AI systems are expected to have that level of trustworthiness. It's just that with medicine, because you're working with more real time, more impactful decisions, we tend to give it more priority. So if you are developing a chatbot for some company or something like that, just intuitively you may not prioritize whether you get the same output every time and so on. So the principles are exactly the same, it's just the priority is more for medicine.
The next question is, how do you effectively explain the concept of trustworthy AI to clinicians who may not have a technical background? What resonates most with them in
Again, all great questions. So I think trustworthy AI as a principle comes from clinicians more. I think AI practitioners come from more from the algorithm development space, and I think the field has benefited from having a conversation between the two. So I would say that most of the trustworthy concerns comes from the clinician side, actually, more than the algorithm developer side. Yeah.
And another question came up. How much domain expertise in genetics or medicine do you think a data scientist, a public health informaticist needs in order to contribute meaningfully to problems like epilepsy diagnosis?
Great. So I don't have any background in medicine, if that helps to clarify that. So I have been working on medical projects for the last 4 or 5 years. And I think the reason that works is because I've been constantly communicating with clinicians. There are many things that I'm learning every day. One of the recent things I've learned is in machine learning, I can just choose, say, 10 features and build a model. But in the real world, choosing 10 features means 10 very expensive diagnostic tests. And you want a model with just 2 features if you can, because you want to reduce the cost, you want to reduce the level of invasive tests for the patient. So this is possible only by communicating with clinicians. But I'd like to say I don't have any background and I've been learning on the fly for every project I've been on. Yeah.
Also, last question. So, with clinicians having limited time because they're spending most of the time with their patients, what recommendations do you have to give clinicians that protective time in order to provide feedback towards these AI or LLM?
Yeah, that's a very important point. I've met clinicians in their clinic when they've just finished patient visit and their time is very limited. I've benefited from being in academic context where there's a lot of free-flowing research collaborations between the two. I usually tend to take a bunch of questions I want to ask. I say, this is what we did before, this worked, we came up with this improvement. Now, this is where we are. What do you think? So, there is a lot of focus on presentation, telling things succinctly, giving the points that you want to learn from the clinician. So, oftentimes the early mistakes I did in my career was I would present my algorithm and say, okay, give me feedback without any structure for the feedback. So now I go asking, these are the aspects I've done, these are the aspects I think something can change. Or also, from a research perspective, from AI, we tend to make the best possible algorithm, the best precision, or the best recall. But that might not be so important in a healthcare aspect. And maybe what the clinician wants is just a list of all possible things. I don't want to know what's the best one. So communicating that and regularly communicating has been helpful. But I also understand when you come from a kind of client space with talking with the client, you might have time constraints, and that's totally valid. And I've just been lucky to be able to have a continuous collaboration.
Thank you, Sowmya, for sharing. Learned so much about trustworthy AI from you. I'm going to hand this over to Morgan.
Thank you.
Thanks so much, Nee. So here we have Monisha, our next speaker. Monisha is a data scientist at Microsoft with over 7 years of experience driving data innovation across Fortune 500 companies, including Goldman Sachs and Infosys. She is a passionate advocate for data literacy and inclusive innovation, actively mentoring aspiring professionals, and was recently named a top 100 data coach by TopMate. In today's session titled AI and Power BI from Zero to AI Driven Interactive Dashboard, in 45 minutes, Monisha will walk us through how AI is transforming business intelligence and making advanced analytics more accessible to everyone. So, without any further delay, I'll pass on the session to Monisha.
Thanks, Madhuram, for introducing. Please let me know if I'm audible and my screen is visible. Awesome. Let me quickly fix this. Awesome. And thank you for welcoming me, and thank you everyone for joining this session. So today's, as Madhuram said, how AI is transforming the business intelligence is the concept. As often as a data professional, you might always work with large, complex data set, and you want to communicate that to a stakeholders in a clear, concise, engaging way, so that a stakeholder or the business leaders know what the complex analysis all about in terms of business terms, right? So in this today's session, I'll walk through 4 of the important topics. The first one is Copilot. If you don't have any experience with Power BI, this Copilot will help you get started into this BI tool. It will help you understand the data behind it. It will help you create a new report and what's that report all about, and also make it more interactive. The second one is, okay, now that we have all the report that's been created, now what's next? How do you actually communicate that to an in an executive summary format to the leaders? And the third one, how can you leverage that to conduct root cause analysis? And the final one is about the Q&A feature and not the Q&A session. So we'll get that after the Q&A feature. So let's quickly get started. So the first one is a Copilot. How can you leverage Copilot in the Power BI to create all your models, reports, measures, everything you want to create a first draft of a report? So let's quickly open all the panel we would need, and also a Copilot feature. So sometimes you have a data model, you know what you want to build upon. For current session, I have created one of the data model that's been already existing. It's not the real data, so it's not the company use data, so it can't be interpreted. For this session, I'll use Copilot and build upon this data model. So imagine that you don't have any Power BI experience and you want to get started. How do you get started? I'll just create a blank sheet. I'll ask Copilot, what content for a new report page would you suggest based on all the available data? So this way, you will know what the data is all about, instead of, because all these data models have been created by the data engineers or someone in your organization, by the data professional. You don't have much understanding of what this specific sales stage is all about. What is this product? Is it a product of uh, a grocery, so a product of a company? What does that all mean? You don't have any information about that and about the data, right? And you want to get an understanding of what is all that data all about from the beginning. So this copilot feature will give you just a start. So it will give you, okay, you can build regional sales performance from all this data, and you can also build opportunity analysis, different views you can build. Let's take this one. Also, one of the key tip I would say here is, you might open a Copilot now. You might open a Power BI desktop now, and then you might not find this all these features. What do I do? Before jumping that, I will quickly tell you how to switch on all the features before interpreting the data that Copilot has created. So for that, you click on options and you go to preview features. I would always recommend you switching on everything, so you get to play with all the features that's in the preview stage, and you can create the most interactive dashboard. So this, maybe we can create one more to see how it actually creates the entire PBI. Do you see this one? This is not that engaging or that super advanced, but then this will give you a base level of what information you are that's been available within the data model that we have. Or in order to understand the data model, you can also connect with data engineers, but if you want to do it on your own, you can always leverage Copilot to create the first view of the data. The second one I would do with the Copilot is some of the features that's available. Like, it can also help you create a DAX. By DAX, I'll tell you what it means. It is a way Power BI uses to create new columns within all the data that we have. So we have all this data linked using different ways to a main model. And I want to create a factored revenue column which tells a sum of a factored product revenue. It's a measure. They call it as a measure within the Power BI language, and this language is how we have Python for data science. This language is called a DAX in Power BI. So you create a measure using this. And how do you create a new measure? You just come here and ask Copilot, explain a query. If you don't understand any of a DAX feature that's already existing in the Power BI, you wanted to play. And if at all you wanted to create a new measure, you can ask Copilot to, in your own language, like you can ask Copilot to actually create a measure for you. In this case, I can quickly show you. I have a factored revenue, which is the sum of factored feature. That's a measure that this data model has. You see all the data measures that this data model has. I want to change this factored revenue from sum to average. What do I do? It's using the Copilot. I come here and ask, instead of sum, can you take average of factored product revenue? And once I click go, it will actually change sum to average. So this will help you understand. You see here how a sum has been changed to average. I'll tell Copilot to keep this code and also update the model in the backend. So this will help you create new features if you want, or new measures. Like by measure, I mean an aggregated feature in the data model. You don't have to learn DAX queries. DAX query can be a little haunting because it's a very simple one. That's why you see just one line, but then sometimes you will have to write 100+ lines of a DAX query. So you can always use this Copilot feature to create one, or else if you're exploring an existing PBI, you can always use that Copilot to change the existing feature. So that's one of a use case of a Copilot. And you can also ask questions. You can ask questions like, what is the total sales? What is the total revenue? So this you can use this Copilot to a most extent as a report creator. And also, if you don't want to, if you are so much familiar with Power BI and you just wanted to do your own DAX queries, but then you feel like the stakeholders don't have an understanding about the data, you can always ask them. Once you publish this report, you can always ask them to, in the published view, create a like switch on the Copilot preview feature, so they can interact with the data instantly, instead of they requesting you a ticket or a feature request and then you had to revamp the Power BI. Hope that helps how a Power BI can be used from creating a report perspective and also understanding the data model, and also creating your own features. The second one, I created a own report based on my knowledge without like created a draft and then enhanced it with all the features that's been available. Okay, now that you created a perfect Power BI, like till now you have been like a base Power BI base user to a medium level user, but now the journey moves from, okay, now that you always I know how to create a Power BI, but how do I enhance it? How do I make it more interactive as a pro user of a Power BI, right? So how to make that Power BI stand smart, like answer all the questions your leadership might ask you. So you have created this beautiful Power BI, and how to make it smart, how to answer the executives' questions that people might get, that you might get. So that's why we have this executive summary view. So you present your Power BI, this dashboard that we created together, to a leadership. Your leadership might wonder, hey, what do you want me to infer from this data? You leaders might not see in the same way you created the data, right? So what's in for them? What do they want to take from this data or this report? So how do you create a executive summary that instantly changes every time a data refresh? So that way you don't have to sit on this report every week, learn. This is a very simple report, so you might think it's all straightforward, but as reports and all, as the information get more complex, you might have to sit the entire one day to get all your information in a more executive format. So this will help you in those situations. How do you create this one? You switch on your build mode, and here in your view, oh sorry, okay, here let's quickly create a new view so I can show you from the beginning. So in order to create an executive view, you just create like click on this drop down Under that, you see a narrative visual that will help you answer all the questions that like leadership might ask you or someone might ask you, and also an executive summary that you can just copy it in your deck if at all you are presenting to your leaders. So here I'm trying to get an executive summary, asking it to provide an executive summary. This is one of my favorite feature. I don't want all this information for my leaders. I just want the information from this one report to present it to the leaders. So what do? I just update it. It creates a beautiful narrative instantly in a second, which you see it here, which gives leaders and highlight of what you want to infer from the Power BI. Also, one of the key tip I would highly recommend it doing it so that you don't have to touch this again at all is this is a very simple data set. This one has data only from 1 year, but as you start using in your organization, you'll have an entire historical data. And if you create something like this, it will actually take an entire revenue across all the years and create the total revenue, which you don't want. Like when you are in 2025, you just want to know about the total revenue of 2025, right? You don't want from 2015 or 2014. What do you do in that case? You just add a filter. You have the slicers option. Since I have only 1 year of information, I am not able to show that. So you just add a slicer telling that, hey, I want to make sure to compare 2024 revenue to 2024 revenue. So this executive summary gets instantly updated with only those 2 years. It will not take all the years from the historical data to give you a summary, right? That's an important tip. I would recommend you using it. And this one, as we created an executive summary, it also helps you answer all the questions from the leadership, or it can also create a bullet in list of insights. You can always create it and update it, so you don't have to it's kind of a self-serve, so you don't have to create a deck separately for your leaders to go through it, right? And the second one is a root cause analysis. Have you ever wondered, like, a Power BI with the help of AI, it can do a root cause analysis on its own? So this helps you save like 4 to 5 hours. So always when you present your report to your leaders, what's in for that is what we covered in the executive summary. And why is that? Those why questions can be answered using this root cause analysis with all the help of the data. So you see a trend here. So every 6 months there is a trend going on, and you want to know, hey, why is there a sudden dip, or why is there a sudden increase in these months? So how do you do that? You can actually spend 4 to 5 hours doing a root cause analysis with using all the features that is contributing to this one feature, or you can also do analyze. You can also utilize the analyze feature that is there inside the Power BI that can help you instantly get what's causing these trend, right? So all this features will help you improve your productivity. That's the end goal behind it, right? So did you notice that I just clicked on one of the box where I wanted to see what's the trend, and right clicked on it and just did search for analyze. You might not see an analyze until you turn on the option preview, which we talked before. So once you turn on those preview features, you might also see all these options. Once you click on analyze, and then you ask it to explain the increase. What does it do? It takes in all the features in the data model that might be contributing to your this one revenue and the opportunity cost, and then it will give you a split. I see now on November 0.13 billion, and on December I see a 0.35 billion. It will tell you which states has contributed to this much of an increase. From this, you will know, okay, these are like an anomalies. These are contributing more to this increase, and then you will dig into it and see what's happening in California or what's happening in Texas, right? Okay, you might now think state might not be a good feature to tell the root causes. So what do? You scroll that and see which kind of a segment that's causing the most increase when comparing November to December. And you have all the information available across all the features. So you instantly get to know what's causing the root cause analysis, and then you can take action upon that. If this is not there, then you might download this data and make a pivot in Excel, pivots, like multiple pivots to understand the root cause analysis. This will give you some time to understand and action upon those changes. Okay, now I think the change is caused by a state. Let's think that. And I also want to include it in the Power BI. How do I do it? I just add it to the page. Instantly, this gets added. So you don't have to click on anything, and it gets instantly added. It will stay the same. So if you, let's take some of the cases. If you think for the next 6 months, now November or next 1 month, November to December increase or quarter to quarter increase is your interest. You always wanted to know what will be the root cause. Is it this one? Then you can always keep it into your Power BI. So people can self-serve based on this. And sometimes in your org or somewhere, you might be interested in quarter over quarter, or it could be a month over month, like 2024 Jan versus 2024 December, 2024 Jan versus 2025 Jan. How do you compare 2 months? It's the same. You just click on 2 columns, whichever that might be interest you, and you click on analyze. It does the same. It'll give you the exact thing which we discussed. And you can also include it into your Power BI to get your faster insights. This is one of my favorite feature. And the next one is Q&A. I would highly recommend you using this. So this is how you interact with the data and creating a visual instantly. For example, always you publish your Power BI, and then you wanted to have this Q&A feature. So if your stakeholder is looking for some information that is not there in your report, but then how do they get those information? They can export that entire model or download this entire PBI, and then they have to create their own Power BI, or they'll have to request you to create to enhance the Power BI using these visuals, right? Imagine that your stakeholder wants to know top states by the revenue for their PPT or for them to present in their leadership. How do you do that? They can't wait or create, wait for a day, or for you to enhance the Power BI, right? So they can simply ask question, hey, what's the top states by factor revenue, by account. So it'll give you instantly a visual, and you can also add this into your chart. So you don't want this visual, but you want this visual by pie chart or donut chart or any a table or matrix, anything. You can just create one instantly. This will help the user as a report user. It will help them very it will be very useful as a report user, and you can add that into your Power BI if at all you want it in your few like upcoming weeks. You can just click on this little button and instantly it gets added to your Q&A will be transformed into your pie chart, and it stays within your Power BI, which you can always refer later in upcoming weeks. So these are the important features that would help you to improve the productivity. So the first one, so I'll just quickly summarize and then we can move to question and answer session. So if at all you are a beginner, you haven't at all used a Power BI and this is the first time you are using a Power BI, then these 5 or 6 items will help you a lot. You can use Copilot to create your base report, or you can ask Copilot to create a chart for you. You can create a measures are of like how in Excel we create a new column like a concat column, or it can be a sum of column A and column B. Here it's called a measure. It's kind of a language, you can think of it. And you can also create description as a report creator. How do you create a description? I might miss that. So you see here, you come to a data model view, and then you click on any of a measure, and then you create with Copilot. It just creates based on the measure calculation. It will create a description format. What does that measure actually do? Here, this average opportunity days, it's how it has been defined is calculates the average number of days for each opportunity. You can keep it. So if at all someone after you leave the organization, someone wants to use this Power BI again, they will instantly know what is this definition about. As DAX gets complex, this will help them a lot. And the fourth one is the learn data models. You can use the Copilot, ask what is this data all about? What is this measure all about? You can it helps you answer all the questions about the data. And the next one is also ad hoc calculations. That is what we just saw. And okay, now that you have seen from a base user how to navigate to a middle like a advanced user. So if you are a Power BI advanced user, how to become like a pro? So that's when you might have to look at these 3 options to make your reports like a self-serve. Instead of you doing all the tasks, it has to do it on its own. So these are some of the important Power BI items I would recommend you exploring to help scale your productivity and also to get the answers fast. And also to become like a superhero in this Power BI. Awesome. That is all I had for today's session. I'll be very happy to answer question and answers.
Thank you so much, Monisha. That was a really power-packed session, taking us from zero knowledge to becoming a pro in Power BI. So, one of the
Of
questions
course.
that I have for you is in your experience, how can AI driven dashboards help teams uncover consumer sentiment or feature preferences more effectively, especially with survey or behavioral data? How would you approach that with, AI and Power BI?
So in order, let me get that question right, Madhuram. So in order to get and understand the survey data, how do I use AI in the Power BIs?
Just not the survey data. Say if you
Mm-hmm.
have different data sources, one is kind of unstructured with, how the consumers feel about a particular product and have given written reviews about it.
Mm-hmm.
Then there is numerical data. So how would you approach this sort of a data set with Power BI and utilize AI to enhance your efficiency, reporting, or self-serve dashboards if the organization is conducting multiple surveys?
Mm-hmm. That's actually a great question of how to use the unstructured and structured data together. So that I have actually had one such data in our daily work. So I can tell you this Copilot and all these features which I explained so far, everything uses Copilot in the backend, and that Copilot will help you interact with the data in the natural language, even if it's survey. How you want to interact, learn more about how a specific survey has performed. How do you merge two models is the only key. So how do you create a model and how do you stitch it? That helps a lot in efficiently utilizing the Copilot to answer all your questions.
So is Copilot capable of doing some sort of sentiment analysis on reviews yet?
Yeah, so it might not be that advanced level, but it's actually pretty good in doing the sentimental analysis as well.
Okay, that's helpful. Thanks, Moni.
Yeah.
So we have another question from Vincent. As a data science undergraduate, what features of Power BI Copilot would you recommend focusing on first to build a strong foundation in data storytelling and business analytics?
What features of the Power BI, Vincent? So Copilot, these are like to my knowledge, these are the exhaustive list Copilot can currently do. So I would recommend you exploring all these features, even if it's like first time you are building a Power BI, or if you also want to start start learning more the Power BI features. I recommend you trying all the Copilot features that we explored now. Hope that helps, Vincent.
Thanks, Monisha. The next question is how much confidence you have in the results of the Copilot?
Oh, that's so I'll tell you. That's there are like so many conversations even in our org. How do we trust this Copilot? Is it giving the right answers, or if is it giving the right information? Because that, if as we start using it, we'll be questioning the Copilot features, right? So one thing I observed is, what do you ask it, that's what it actually returns. So one of the when talking about the executive summary, you might think that, oh, these information might be right or might be missing something, or this is not the exact numbers. I don't think these numbers actually tells the story. how do you do that is using the filter. You tell Copilot, hey, don't take entire data, just use these filters to answer the question. So that's one of the main thing, like a tip I would recommend it. So Copilot understands what you actually looking for. So what you give as an input is what it actually gives back, is what I believe. And the second one is, how do you actually stitch the data? So some people I have seen, they don't actually stitch the data. They just import it and use VLOOKUPs to get all this information into the fact data. But I would highly recommend it like correctly or properly stitching every data you bring into the Power BI, so it can actually answer you all the questions. And one of the cool feature, while I was exploring it, I've seen it, it actually tells you the exact source date, the data set and the column it's using to answer your question. So I use the Copilot often, and I also tell my stakeholders to, hey, ask Copilot if at all you have some simple question. So they use it. So I'm pretty confident on that. Maybe you can explore it and tell me if it's not that good.
Yeah, thanks, Monisha. Our next question is,
follow up, if I may ask. What are, I mean, do you use this in your daily work and your management and all are okay with it? Or do they have like guidelines or anything in for use? Like, is it only for exploratory or do you actually use it for your day-to-day work?
So it's that's a great question, Nishan. So this has to be taken with little salt. Like it you can't exactly like it gives you what you based on the back end data, but then if you think that the back end is not that great, then it will also, the output will not be that reliable. For like, we actually use all these features that I explained. Like for a self-serve, we have it in all our dashboards, all like the summaries, question and days, tool tips, all the Copilot features. This one you see here, these for exploratory purpose, I would recommend report you as a report user, they use it. But as a report creator, I would use last three in every report I create. And it's been actually used as well. So we do use that. We do have that in all our reviews, but then it has to be taken with the salt. It's all based on the backend data, how it's been built, how accurate it is. Does that answer the question, Ashwin?
Thank you.
so the next question is, how does Copilot assist in preparing data?
As in preparing the report,
Probably the question is more geared towards in data preparation, maybe along the lines of data cleaning.
Okay. I haven't done for the data cleaning purpose, like ask it to remove those inappropriate rows, or or change those missing values, or do those things. I haven't done on those perspective, but it helps to create a new feature or a new column, if at all. That was a question. Hope that answers.
Yeah, I think so. And we have one more question. How do you ensure AI insights in Power BI are understood and trusted by non-technical stakeholders?
How do you ensure the Power BI the insights on the Power BI are understood? So as a non-technical stakeholder, it's like similar to what I answered to Nishrin. So for a non-technical stakeholder, you might you have lots of business knowledge. You might have to take it with grain of salt. You also want to make sure from the business context that's all this summary is accurate, all these numbers make sense to you. Okay, I see a total revenue of these many, but does that make sense to you as a business user? Because you might, as you start learning about the business, you without it can't be the exact number you knew already before you are looking at the data, but you might have a gist of, okay, it should be more than 200 million, or it should be more than 200 million and less than 210 million. So that kind of a context, if you have, so this will help you answer those situations if you have a business context prior.
So, uh, I mean, building on these questions,
Mhm.
how is your team or organization making sure that they adopt this AI in Power BI? Do you see and experience more leaders more leaning towards, making sure that team members are using AI? Or is it something that you have been exploring on your own end? How is the organization?
On the org end, I would definitely tell that we're all moving to AI world, right? So it's highly recommended for every person to. It's not the personal exploration. I would say it's highly recommended on the org or the company level to move everyone to a AI data driven mindset. So
There
it
is
has.
there is more focus on, making sure the team members are using AI.
Yeah. So one of the person one of our leaders once said, if you're not using AI at least 5 times a day, you're not using that to your fullest. So at least now it's 5 times a day, but then as AI gets more advanced, then it will be highly recommended to use more than that. So we do use Copilot a lot.
Sure. Thank you so much, Monisha. I think it was a really wonderful and a very useful workshop for all of us to make sure AI gets incorporated into our daily data analysis also. And with that, I'll thank you for being a speaker and doing this workshop for all of us.
It's my pleasure, Madhura, and thank you for inviting me. It was a great session.
Thanks. So with that, we will move over to our next speaker, Anusha. Anusha is a data scientist at Snapchat based in Palo Alto, California, with over 12 years of experience focused on machine learning and data driven solutions. She plays a key role in shaping ad strategy and improvements by translating data into actionable insights and influencing roadmaps through rigorous experimentation. She is passionate about using data science to solve business problems and drive innovation. Without any further delay, I'll get you started with your presentation, Anusha.
Thank you, Madhuram. Hello, everyone. Let me go ahead and share my screen. Let me know if my screen is visible to everyone.
Yeah.
Awesome. Hello, everyone. Thank you for being here today. Today, I would like to talk about AI frameworks for automating data analysis in general. So let's start with what is EDA. So EDA is essentially exploratory data analysis, as most of us are familiar, because it is one of the most critical steps that we do as part of any project. It could be, ad hoc analysis that you might be doing, or it could be more advanced statistical machine learning model that we perform. EDA is a crucial step. So essentially, it helps analysts and data scientists understand the data structure, extract any patterns from it, and key features of the data before any sort of like modeling or any other advanced projects we take on. EDA helps uncover essentially any sort of data quality issues. This is fundamental. Data cleaning is fundamental, so you can extract better insights out of it. So essentially helps understand missing values, duplicates, outliers, etc., patterns and trends that may emerge out of the data, which indicate seasonality or abnormalities in data or any sort of like user behavioral patterns that we can extract. And most importantly, as we think more about statistical modeling, it helps us understand the relationship between different features and the target variable that we are modeling for. So now let's talk about like data preparation and EDA in general. And as we all know, anyone who has worked on a data science project would understand this, that EDA is one of the most time-consuming steps. And Forbes once quoted 80% of the work is actually spent on EDA. I tend to agree on this. In addition to storytelling, right? Preparing a compelling story and presenting, that to me is another big step. But essentially, a lot of work goes into like EDA, and that is why I wanted to highlight some of the challenges that we have today with the manual EDA that we do. I think we still are heavily reliant on this. And as we bring more AI into our workflows, where I see this is going. So let's talk about some of the challenges of manual EDA, right? Like, why do we have to think more about AI-driven EDA? First, we need to understand the challenges that exist today. So time consumption, as we all know, EDA is extremely time consuming. As I quoted previously, that a majority of our work actually goes into it, data cleaning, data preparation, and also like extracting the patterns. And it's repetitive work. And obviously it's prone to like any sort of like errors or inconsistencies depending on who conducts the analysis. And I mention who conducts the analysis because as we see, a lot more PMs are getting involved these days in doing their own analysis. So I also see a lot of errors and inconsistencies on how they're querying the data, which is concerning to some extent because they might end up extracting some misleading results and patterns, which might end up leading to poor decision making for product strategy. So it's important to also bring in AI there so it's much more automated in a more consistent way. Obviously, if you need to perform EDA and extract the right pattern, it takes a significant technical expertise, in my opinion, and domain knowledge and subject matter expertise of the data set. You need to understand the data because data can be sourced differently. And if you don't fully understand like how the data is being sourced, then again, you might end up querying it incorrectly. And one of the biggest challenges that I see today is that we don't really have a standard framework or steps as to like how one should go about an EDM. Again, it doesn't have to be prescriptive, but some methodology, some framework where there's some consistency to how we think about it doesn't exist today. It varies widely, even across data scientists, how they think about the problem space and what kind of patterns they extract out of it is vastly different based on their own experience and skill sets. And if we bring in PMs into this equation, it again varies even vastly. So why should we automate with AI? Some of the challenges that I mentioned is that like it's time consuming, it's repetitive. So with AI, their goal is to deliver much faster insights, a more consistent insights, relevant findings. So essentially, what we want to do is really accelerate the time that takes to perform some of these repetitive tasks and accuracy. Like I mentioned, some of the challenges we have today is inconsistency in frameworks on how we approach an EDA problem. So to bring in more consistency, with that comes more accuracy and obviously automation, right? When we are able to automate things, we as data scientists can then focus that time on building a much more advanced, technical capabilities or focus on really incorporating insights into product strategy and really drive the product strategy instead of continuing to do the repetitive tasks. Let's before we dive into like what exists out there today, let's talk about some of the applications of AI-driven data analytics. So what are some of the different fields where we can apply AI-driven data analytics? So obviously I work in social media, so that to me is the first thing that comes to mind. In addition to social media, you can apply this in fintech, healthcare, e-commerce, cybersecurity, smart manufacturing, and many, many other industries, of course. I just wanted to highlight a few of them here. What are some approaches today to think about automating EDA? I just want to point out that I don't think we are at a point where we can fully automate exploratory data analysis, but we can significantly reduce the work that we do on it, utilizing some of the existing tools. So I would like to highlight a few different approaches that we have today in adopting the automated EDA approaches. First one being, we have some low-code platforms out there that we can leverage. So what are low-code platforms? You hear this term coming up in a lot of different areas, including software engineering. The idea of that is you leverage an existing AI-driven data analytics tool. Power BI is one of them. IBM Cognos is another one. Where with minimal to no coding capabilities, you can pretty much automate the analyzing the data, exploring the insights, and also setting up the frequently monitored reporting for the data. And then one such example, I copied this from like IBM Cognos. It's being sourced from there. It is this exactly what it does. Is you can turn on the insights, and then also it creates a story for you, right? It significantly reduces the time in obviously like monitoring the patterns and looking through the patterns and then writing a write-up of what we're seeing from the insights. So it can significantly bring down the time that it takes. So one option is for companies to look into leveraging low-code platforms that exist today. Other options are building our own custom AI-powered EDA workflows. And there are two types here that I would like to point out with a few examples. Some of them can be done by data scientists, leveraging some of the existing packages that we have out there, like Python code packages. And few examples of those libraries are, Pandas profiling, SweetViz, AutoViz, etc., which I'll demonstrate in a little bit how they work. And the other option is a more advanced, a more sophisticated framework that supports more advanced data science that work that we do today, like predictive modeling, user feedback loops, and dynamic insight generations and stuff like that. And I'll show an example of how Meta is doing it today in one of the next slides. So let's start with the first one. When we think about how can we automate with some of the existing Python libraries that we have, just with a few lines of code, right? In the past, I want to say in the past, because I know a lot of people are actually moving into leveraging a lot of these tools that exist out there to boost their own productivity. So essentially, before you, again, as part of EDA, data cleaning and understanding some of the data nuances is one of the big steps, right? So Pandas profiling is a great library that can actually help automate some of that. With just like literally a few lines of code, it can tell you like some of the basic profiling of your data, which then can help you understand your next steps. Either you impute missing values or ignore missing values, whatever steps that you want to take after. This is one example of that. And the other example is around data visualization. So again, literally with just two lines of code, you can create a ton of visualizations based on your own data set. Obviously, this data set, these visualizations make sense. But for a different type of data set, AutoViz would generate a different set of visuals that make sense for that data set. So the idea here again is that excuse me, just with two lines of code, you can automate a lot of data visualization as well. Another thing I would like to talk about is how some of the companies like Google and Meta are trying to build data science agents. To give you an example, on March 3rd of this year, Google rolled out data science agent that is meant to automate a lot of data science workflows. However, I do want to point out, I tried and tested this. I have noticed significant gaps. I don't think this is by any means a replacement for data scientists, or it's by any means is there at a point where you can fully rely on it. You can try this out on your own and kind of see, if it makes sense for you, if you like it, or if it works effectively. To me, I didn't feel like it's at a point where it claims to be. So essentially, the idea here is that you can upload a data set. It's the example taken here is uploading a CSV file, but you can actually connect it to BigQuery, which is the Google UI for querying, or you can connect to Google Drive itself and import a Google Sheet into it. And essentially, once you bring in the data, you provide it free prompts. For example, you can provide a prompt like, can you help me analyze user behavioral differences by geo, as an example? But you can provide a number of prompts that make sense for your data. And then Gemini would then automatically generate insights and a story with the insights. The challenge that I see today is that it's very bad at taking follow-up prompts. It gets stuck in a loop. It doesn't quite understand when you give it follow-up prompts, and it didn't necessarily take into account some of the data nuances that exist, making it unreliable today. With that being said, one use that I see for this is that some of the pivot charts, maybe that product managers use for some basic data analysis purposes, can be automated with this. Say, for example, they're simply looking at count by certain geo, like how many users do I have from geo, as an example, right? For a specific area that they might be investigating. This can be a great tool. They can upload the CSV or bring in the Google Sheets data in here and provide that quick prompt, and it can then generate the charts for you in matter of seconds. So I see that being a target user for now, which is product managers and aspiring data scientists. However, obviously it's in a very early stage. So I see this evolve into a much more technically capable agent, not just from Google. I know some of the other companies are trying to do this as well. A lot more might come in the future. But personally, I don't think it's something to be alarmed as a replacement for data scientists. The way I see it, it can enable data scientists to be a lot more productive and do a lot more in a short amount of time. And instead of being stuck in a more repetitive ad hoc analysis kind of tasks, you can then actually really focus more on strategic insights and really help shape the product direction. That's how I see these tools enabling data scientists in the future. I also mentioned another approach to this is obviously when you're thinking about building custom EDA workflows in your company, a more sophisticated version of this can exist. In fact, we are actually working on this at our company right now. And this requires collaboration between machine learning engineers, data scientists, and software engineers as well, because it's a lot more advanced. I just wanted to show an example of how Meta has recently released this and how they're implementing this into their ad ranking. So given I work on ads, this is of interest to me. That's why I kind of wanted to surface it to the rest of the folks. And it's an open source article. Feel free to take a look. Essentially, what they're doing is that they're more dynamically reacting to the ads based on user behavior within the same session, right? In the past, that behavior was not real time. There was delay, like I believe it was 3 days or 1 day. I don't really know, but there was a delay to a point where you cannot immediately react to. Say if someone is, the example that they gave, say if someone is searching for ski resort ads, then immediately you show them, ski equipment or lift tickets, etc. So previously, the drawback was that immediate response was not real time. Now it's more real time. That's because they're able to utilize the sequential learning into their ad ranking that then feeds into the feedback loop very quickly. And the results, as they pointed out, they've seen a 3% increase in conversions based on testing with a selected segment. I want to point out also that any small lift in conversion, even like 0.5% lift in conversion is very hard to achieve. Conversion essentially here means purchases that they get, right? Someone checks out an item and buys that item. That's what conversion rate is. It's incredibly hard to lift it. And when you do, even small lifts can actually lead to significant amount of revenue gains. So 3% might seem small here, but it can actually translate to huge amounts of revenue gain for the company. So this is another example how companies are adopting AI-driven approaches, not just for EDA, but also within their personalization systems and how personalization can be influenced using some of the advanced AI techniques like sequential learning or reinforcement learning and things like that. So I just wanted to share those are the few things that I see happening in the market today. And if we have time, I just wanted to do a quick activity time, but if we don't have time, that's fine too. Let me know.
Sure,
No,
go ahead.
Awesome. Yeah, I wanted to do a quick brainstorming session. I wanted to understand from you folks, like how would you implement EDA automation in your organization? And if you can take a couple minutes to jot down the thoughts and then reconvene to share a few ideas, I think everyone can benefit from, sharing ideas with each other. Does that sound good?
Yeah, or people can just start talking if they have any.
Yes, please. That's fine too. Yeah, let's give a couple minutes if that's okay. Maybe we can 207, 1207.
I mean, I'm working as an intern right now, so I can probably start, and maybe others might follow. So I would like to, if I have a lot of survey data, uh, I might want to first make sure the survey also collects their geography and the time of the survey, and so automate it based on stitching the data set itself in the back end so that we can combine all the surveys to get a more holistic picture of what the consumer preferences are, and then go on with utilizing the AI EDA tools like you are mentioning for Pandas query to get a better idea. And since this would be the first time I would be using it, I would still be a little bit cautious to make sure if my analysis matches with what the output of AI itself, because I've used Pandas and I wasn't actually aware of there was already AI integrated into Pandas itself, which is really cool. It's going to save a lot of time. So if I'm comfortable with using it again and again and the results are similar, it would be much easier because if the survey data or the survey itself is structured in a similar way with a similar objective, so it's going to help the team in the long run to save a lot of time, and those time can be utilized for something more productive for a business strategy itself.
Agreed. Well said. And I like your point around given we're still like early stages of it, we still need to like manually review it. I think that's a fantastic point because I don't think we are at a place where we can completely trust the tools as they're prone to errors. So I think it's important to still keep an eye to make sure that the quality of the data makes sense and the insights make sense. Um, with that, also you can check out the Google Colab and see if the Gemini data science agent that I was talking about, see if that satisfies your task requirements as well. It's something to keep an eye out because I do feel like they're going to come up with a much more technically capable agent in the future, even though their first release was not as successful. But I see that evolving very fast to a point where it might actually be pretty good for a data scientist to perform their tasks.
Thank you so much. And it was also reassuring that it won't take the job of data scientists.
Yeah, I think that at least I don't think that would happen personally. I think the way I see this is these tools can be hugely beneficial to enhance the productivity, right? Because today, as data scientists, I think we spend a lot of our time doing a lot of repetitive tasks. Even for me, like I've been in this field for so long, there's still a lot of repetitive questions that come up. What happens is that you can't really focus on things that you want to, which is how can you influence the product roadmap and strategy? Because to me, that's where the real value of data scientists comes in, is shape the product direction, right? So with automating some of these repetitive tasks, you can really then focus on adding value in that space. That's how I see it. Others may have a different perspective, but this is my own perspective of this. Thank you for sharing, Madhuram. I know we're slightly over time, so I guess we can end it here. But yeah, feel free to reach out to me if you have any questions.
Yes, so thank you so much, Anusha, for a power packed session, and it was I would say insightful and also very relevant in terms of what technologies are available. Something as recent as this March that came out for data science people. So there will be a lot of takeaways from your presentation that we can use. And with that, I would definitely encourage audience to reach out to Anusha, as she mentioned, to answer your questions or queries that you have. And we as a team from with Silicon Valley and myself would thank all the speakers that came in today, took time from their schedule to make sure they shared their insights to all the data aspirants and audience here. And if you missed any part of today's session or you want to revisit it, the recording will be available soon on our YouTube channel. And I would like to remind all audience here that we are not done yet. We have one more day of sessions where esteemed speakers from the data science field and experts are coming in, which is tomorrow, to share their knowledge on healthcare, cloud, Gen AI, and careers. And it's also filled with hands-on workshops in data science. So mark your calendars and do come up for this upcoming session tomorrow and get ready to dive a little bit deeper into these topics that matter the most at this point. So we will see you all tomorrow in our session again.
Thank you, everyone. And thank you especially to the speakers as well. We really appreciate you supporting WIDS and its mission. So thank you for that. Bye, everyone. We'll see you tomorrow.